right side. So this is the characteristic image from the okay. Okay, we can see you outside. Without coming out of the. So now let us discuss some questions. This is 140, then this will also be 140. Today we will explore the magic of image formation in plane mirror. We'll see how light reflect and create the image you see every day. See these pictures. So hello everyone, my name is Amit Gupta. You're watching this YouTube channel Physics Analysis. Let's get. So today's class is image formation in plane mirror. In previous lecture we discussed in a mirror how a mirror can perform a regular reflection. So here let me consider one light ray incident at the point of incident O, and this AO is the incident ray. Ray is going along OB direction, so AO become the incident ray, OB become the reflected ray. If we consider a normal to be drawn perpendicular to the surface mm dash, the plane mirror, ON is the normal. So we have seen according to law of reflection of light, this angle will be equals to this angle. Angle I is equal to angle R. And let me ensure you that plane mirror shows regular light. Something I would like to indicate you about object and the image means what? The image means what? The meeting point of reflected ray. Suppose this is the mirror, and before this mirror one object is there. Image we are getting of this object. This is how light rays after reflection meeting or appear to. Here in this case, since we have taken the plane mirror, here the incident ray after reflection, this is how it will go after reflection and will not meet. So when extended back behind the mirror, it will appear to meet somewhere where virtual image is being, right? So image means what? Case I am taking into the concave mirror, okay, the principal focus, the optical center P. Let us consider this focus. This is the center of curvature. One object is being beyond its center of curvature. Now what will happen? Light ray will go parallel to the principal axis, which will go after reflection passing through the focus. Another ray if I'll take passing through the center of curvature, it will reflect back in the same medium, okay, and here they will meet. If this is AB object, then this will be image as B dash, right? So here in this case, this is the incident ray that is coming out of a object, and this is the reflected ray, right? This is the reflected ray and this also is the reflected ray now, and here this meeting is the meeting of reflected ray which forms an image. So about image you can say that meeting point of reflected ray, forms an image. Same you in case of object. See how in object also this incident ray is meeting where? At this point, like object. So about object I can write the meeting point of incident ray. So the meeting point of incident ray forms an object, and meeting point of forms an image. Image can be point size, can be extended size. Object also can be point size object, can be extended size object. Here in this case extended size image is there, in this case also extended size image is there. Let me show you point size object. See, if this is the mirror and this is the point, light ray after passing through this reflecting surface goes along this way, goes along this, and if this is the object, this will be the image. So here the point size object we have taken, and here this is the extended size object. This is point size image, and this is the extended size image. Okay, this extended size image consists of some height, and in case of object, in case of this point size, in case of extended size, it consists some height. Look it here. Here, height is there, and no height is there in point size. So object can be point size, object can be extended size, image can be point size, can be extended size. Okay, so the main thing is image means intersecting point of reflected ray, and object means intersecting point of incident ray. So forms an object, and the meeting point of reflected ray forms an image. Okay, next page में समझते हैं. We discussed image means meeting point of reflected ray, meeting point of reflected ray. So the meeting point of reflected ray forms an image. Now let's talk about the type of image. We discussed point size image and extended size image. This is the point size image, and this is the extended size. Extended size image, some height. Point size image, light is coming out of object, point size object, in all possible direction, right? And from this extended size also, light is coming out in all possible direction from every point. Okay, present in this. Okay, see, if this is an extended size object or image, what you call, billions of light rays are coming out from every point present in this extended size image or object. So just now we discussed that image can be point size, can be extended size. Object also can be point size, can be image size. Now we are seeing in terms of real image and virtual image. Okay, so image, we have divided image into two types. One is real, and one is virtual. Okay. So let us understand what is real image and what is virtual image, and the difference between real and virtual. Right? This is the real. If this is the virtual, real image and virtual image. So the real means you can obtain on a screen. Can be obtained on a screen. Can't be obtained on a screen. Virtual image. Right? This real image is inverted, and this virtual image is erect. Okay, and light rays after reflection, they actually meet at a point. Actually meet at a point. Real image is formed. But when light rays after reflection, they are not supposed to meet actually, they appears to meet. They appears to meet. In this case, virtual image is formed. Alright. So image can be real, can be virtual. See, I am giving you one example. If this is the mirror and this is the polished surface, and this is the point I am talking about, the light ray will come out this way, return back in the same medium. Why? Because this light is falling normally to this plane. Another ray, if I will take this ray, this one, it will go along this way on following law of reflection of light. So when traced back behind the mirror, we'll see that both the rays appears to meet somewhere behind the mirror, which form. So here you can see this reflected ray are not meeting, but they are meeting there to meet somewhere. Okay, so that's why this is virtual. This is not actual. Virtual image. So just like in this, just like image, case of object also. In case of object also, if I am talking about object are also real, object are also virtual. I am giving you one case. Let me consider this is the mirror. Let us suppose this is the polished surface. The front side, this is the reflecting surface, right? You consider a case where light rays are coming like this, and this is the incident ray. right? Which is after reflection going along this way. Okay, understood? One light ray is coming along this way also. After reflection, they meet. So this way, this will become what? This is the incident ray, which appears to meet somewhere. But this incident ray meeting, we call it what? Object. But here, these two incident ray, they are not actually meeting. They are appearing to meet somewhere. So this, the object we are seeing here, this you can consider the virtual object. The virtual object. Okay. In that case, this will be the real image, right? So why real image? Because this is the reflected ray. This is the reflected ray, and this is the incident ray. So incident ray meeting and reflected ray meeting called image. So by meeting point of incident ray forms an object. I hope you have understood the concept of real image and virtual. Okay. So moving on to the next part, image formation. How exactly image is being formed? See. So let us draw some pictures and let's check it out. How exactly image getting? Okay. So let me consider one mirror, and this is the light ray. Can consider this to light ray which is coming out from some point urgent in object. This is the object we have considered. This ray I have taken which is falling on the surface, the mirror, normally to it. So it will retrace its path, will take back behind the mirror. Again this one, this is how it will go, will take back behind the mirror, and we'll see that these two rays, these two the reflected rays I'm talking about, this one now becomes reflected ray, appear to meet, where an image will be formed, and this image we'll call it the virtual image. Which kind of image now? Virtual image. Which kind of object? The real object. Okay. If I want to obtain an image in case of plane mirror, three elements we need to take care. One thing is placement of object. You make sure that the object is being placed in front of the mirror so that light rays coming out, so that the light rays coming out of the object would fall on the reflecting surface of the mirror, right? And second, you follow the laws of reflection. Here I have followed the laws of reflection. See, you can ask me this question, that why this racer after reflection will go in this way, in this direction only. So I will tell that on following law of reflection. You can draw one normal here. Okay. So you have one angle of incidence. So you know that according to laws of reflection, this angle of incidence is equal to be angle of reflection. So in order to fulfill the laws of reflection of light, this light ray after reflection will go along this way only. There is no other option. There is no other path or direction other than this. And now when traced back behind the mirror, it will appear to meet here where the image is formed. So in this way, if the image is being formed now, this has some characteristics, some property. So that also we will discuss here. Okay. So let's draw some. So these characteristics I am discussing to the next page. Okay. Okay. So let us now consider the characteristics of image formed by a plane mirror. Okay. So you can note it down that the properties of image formed I am going to discuss here. See, when we observe the image formed by the plane mirror, we see that what the conclusion we are seeing. Look at this picture. In this picture we have seen, we see that the object height is equal to image height, and the image is being formed as far behind the mirror as the object in front of it. See, look at these pictures. We have seen that the height of object, height of image. In this case also, height of image is somewhat equals to the height of object. The object distance is equal to image distance. The image is erect, it's not inverted. The one thing is we are observing, the one thing that, see, the left side of object is appearing in right side in image, and right side of object is appearing in left side in image. Okay, this part is unique. We have the conclusion that what the image we are getting from the mirror, if I'll take one mirror, okay, let us consider one object AB is placed in front of the mirror, then light ray will come out. Okay, another light ray, if I'll take, this is the another light ray. Both the light ray, since both the light rays are normal to this mirror, so it will go back in the same medium. When traced back behind the mirror, they are not appearing to meet. But when I'll take any other ray, okay, we'll see that these ray after reflection they appear to meet somewhere where a image is being. So if this is AB, the object, then this is the A dash B dash the height, the image. Right. Here, look at this image, and what are the observation we are seeing? We can conclude the image formed by plane mirror is, of course, it is virtual. Why? Because it is not meeting actually. In fact, they are appearing to meet. Okay, and erect. You can see the object is erect. If this is P, then this is the image. This is erect, of course, right? So if this is P, then this is also image formed in plane mirror is virtual. Image is erect. Image of same size. Image is formed at same distance is equal to image distance, right? So if it is U and this is V, then U is equal to V in case of image formation in plane mirror. So the first property we are saying here, the virtual image, and second property erect, third one same size, fourth one same distance, fifth one what we are seeing laterally inverted. So image formed, this property we call it is sideways reversal. This left side of object appear to be in right side in image, and right side of object appears to be in left side in image. This sideways reversal is called lateral inversion, and the image formed, and hence the image formed in plane mirror is laterally inverted. This is very important, bacho, and you might have seen in ambulance. This is how ambulance is written, so that who are on road, ambulance means emergency. So you could read, actually it is ambulance. So characteristics of image formed in plane mirror is virtual, erect, same size, same distance, attainable. More are also there, but no need to discuss, I think, here. Why? Because stick to the syllabus. Mirror is rotated by theta angle, okay, to the incident ray. Suppose this is the incident ray, and to the incident ray one mirror is rotated by an angle theta. थीटा एंगल से अगर कोई मिरर को हम थोड़ा रोटेट करें तो इसका जो रिफ्लेक्टेड रे है ना वो 2 थीटा से रोटेट हो जाता है. फॉर दिस रे इफ आई ड्रॉ द नॉर्मल and if the rotation, the angle, if the mirror is rotated by theta angle, then this normal will also be rotated by theta angle na. Okay, so on following laws of reflection you can calculate here, okay, this angle minus this angle, you will get 2 theta. Next, if I am saying object distance is equal to image distance, so this is applicable in case suppose an object is coming approaching the mirror speed, the image will also approach the mirror by this speed only. Relative to this object, this image will appear to be 2u. So if I ask you, what if an object is coming or running toward a mirror at the rate of 20 km per hour, then what is the speed of image relative to the boy. So you must say 20 if the object is coming, if the object is running at the rate of 20 kilometer per hour, the image will also run at the rate of 20 only. But relative to the object, it will appear to be 20 into 20, 40 kilometer per hour. Okay. So this is the characteristics of image formed in plane mirror. Okay. Now let us discuss usage of plane mirror. What are the use of plane mirror? See, plane mirrors are used in as a looking glass also. This use is very common. We all are using this plane mirror looking purpose, right? Okay, for looking purpose we are using plane mirror. In periscope and kaleidoscope. Kaleidoscope, you know, na device which is based on multiple reflection, where we can get a pattern. Okay, this is how it looks like. The last end you can cover, okay, by a paper, and inside you can fill something, some like excess of angles and all. And here also you cover and make one hole. And if inside all the three walls are plane mirror, such a arrangement is a kaleidoscope. When you see from this hole, pattern, remarkable pattern will be coming. Okay, this submarine also and other military applications. So here periscope utilize two mirror. See here, two mirrors are placed at 45 degree. Object, suppose this is the object, you can see this object from here only, from the other side. Light ray from the object, the reflection the first mirror, this reflected ray again will reflect from this mirror based on the other side, and this is how, okay, we can see view outside without coming out of the, okay. For decoration purpose also we are using plane mirror, right? Plane mirror, basically these are the uses only. So now let us discuss some question answer. Taking one question here, a light ray approach a mirror at an angle incidence 25 degree, find the angle of reflection. It's a very simple question. Suppose this is the plane mirror and light ray is being incident at 25 degrees, is 25, then reflected ray then angle of reflection will also be 25. Yes or no? According to law of reflection of light, I is equal to R. So if I is 25, then R will also be 25. Okay. So moving on to the next question. A light ray approach a mirror at an angle of 22 degree with the mirror surface. So what is the angle of reflection of light ray? So let us suppose this is the mirror. One light ray is falling this mirror at an angle 22 degree the surface. You know, this is the glancing angle, and if you will take the normal, this will become 90 minus 20, that is 68 degree. So if this is 22, this will be 68, and on following law of reflection of light, if this is 68, then this will also be 68. So R is equal to 68. Okay. Third question. Pin is placed 4.9 centimeter from a plane mirror. How far behind the mirror can the image be expected to appear? See, if this is the object, right, and the pin is at a distance of 4.9 centimeter, then the image will also be appear at 4.9 centimeter, right? Related to this point, it is 9.8 centimeter, but behind the mirror it will also be appear at a distance of 4. Now find R when the light ray is incident normally. Light ray is incident normally to a plane mirror. Suppose this is the plane mirror and light ray is incident normally in the sense it will retrace the same direction. Okay. So here is the angle between incident ray and normal. Angle of incidence I is equal to 0. Now it return back in the same medium as per the principle of reversibility of light. So here R is equal to I according to law of reflection of light, and I is equal to 0 degree. Then I is equal to R will also be 0. So here R is equal to 0 degree. So if a light is incident normally to the surface, to the plane mirror, then R will be 0. I will also be understood. Now I am taking one more question here. One light ray is coming. This is how one light ray is coming. Now after reflection by the mirror, this both the mirror are placed at 70 degree inclined to each other. This angle is 70 degree to this incident ray. After reflection again will be reflected back, and if this was the incident ray, this incident ray deviate from by this angle, d angle. If I want to ask you find out this d, then how to find out? So let us see this question. See, if this is 70 degree, if this is 70 degree, right, then this will also be 70. Why 70? Well, corresponding angle, these two rays are parallel to each other. Okay, this is given in the question that these two rays are parallel to each other. One incident ray is coming, parallel to the second mirror. So if this is 17, then this will also be 70, and if this is 17, then this will also be 70, glancing angle, right? So if this is 70, this is 70, then this will be what? 140, 180 minus 140, that is 40 degree. This is 40 degree. Now if this is 40 degree, then this will be 50 degree. Why? Because if this is the plane mirror and this is the normal we consider, then 90 minus 40 will be 50. So if this is 50, then this angle, the whole angle will become 40 plus 50, that is 90. 50 plus 50, that is 90. If this is a 90, so the whole angle you add 40 plus 50 plus 50, 140. So if this is 140, then this will also be 140, corresponding angle. Okay, the answer will be to practice more and more questions. That's all for today.